Okay, I want you to really picture this. Imagine you're sitting in the exam hall. The clock is relentlessly ticking down. The silence in the room is absolutely deafening, right? And you flip to the final section of your Cambridge Computer Science 9618 paper. Staring back at you is this massive, incredibly complex block of low-level code. I know exactly what happens. Your heart rate spikes, your palms get sweaty, and panic starts to set in. But take a breath. Welcome, everyone, to the Olympic Decathlon of Computer Science exams. Today, we are breaking down the ultimate Cambridge exam strategy, and we're going to focus deeply on the assembly language instruction set. Specifically, we're talking about JPE, JPN, in, out, and end. I'm your host, and in this explainer, we are going to completely transform how you approach these exams. We are treating this syllabus like 10 different disciplines with 10 unique challenges, and we're going to train to master absolutely every single type of question they can possibly throw at you. Are you ready? Let's get into it.
So this insight right here comes directly from a senior Cambridge examiner, and honestly, it is a massive wake-up call. They said the difference between a B and an A star in computer science often comes down to how well you understand assembly language. Now, you might be wondering, why is that exactly? Well, let me introduce you to two very different types of students we see taking this paper every single year. First up, we have Alex. Now, Alex is brilliant at memorization. Alex completely overloads the answer sheet with raw computer science facts, defining every single acronym flawlessly. But the catch, there is absolutely zero contextual analysis. None. And then on the flip side, we have Sam. Sam is a super fast thinker, really sharp, but constantly rushes under pressure and completely misses the specific requirements of the command words in the prompt. Both Alex and Sam are literally leaving massive amounts of marks on the table. It's heartbreaking to see, really. But today we fix that.
Okay, let's dive into this roadmap. First, we'll establish the core principles and frameworks. Second, we'll unlock what we call the method mark strategy. Third, we'll look at systematic procedural execution. Fourth, we're going to expose the top 3 examiner traps so you don't fall into them. And finally, we'll wrap up with mastering comparative analysis. Let's kick things off with Act 1, Core Principles and Frameworks. It's time to define the playing field. So the Cambridge Computer Science syllabus, whether you're looking at the foundations or you're sitting the advanced 9618 paper, it requires so much more than just rote memorization. The theoretical architecture demands a deeply connected conceptual understanding. In fact, a direct examiner alert pulled straight from the principal examiner report states super clearly that candidates consistently confuse key terminology within the assembly language instruction set. That's easy marks lost. So let's define the core movements of this decathlon right now so we're all on the same page. In literally just takes an input from a device or user. Simple enough. Out sends an output. Now for the jumpers. JPE stands for jump parity even. This alters the flow of execution, jumping to a specific label if the parity of the accumulator is even. JPN stands for jump positive, so it's jumping to a label if the value in the accumulator is positive. And finally, end, which terminates the program execution. The examiner alert warns us that you absolutely must always define these terms clearly before you start throwing them around in your extended responses. Let's see exactly how these concepts fall apart in practice when you're in the hot seat. Let's take Alex's answer to a scenario about checking system temperatures. Alex writes, in takes input. JPN jumps if positive. JPE jumps if parity is even. Out outputs. Okay, sure, those facts are correct, but that is a massive fact overload with zero contextual analysis. Alex didn't mention the temperature sensor a single time. The examiner doesn't know if Alex actually understands the system. Now look at Sam's answer. The exam's command word was evaluate the use of JPE in this code block. Sam just writes a description of what the code does, completely ignoring that critical command word evaluate. Evaluate requires looking at the strengths, the weaknesses, or the alternatives. These flawed approaches lead straight to red pen marks, folks. Examiners do not want a dictionary. They want to see your brain actively working through the specific problem they gave you. Moving into Act 2, the method mark strategy. This is all about winning those precious marks through process. Think of this as your technique training. It is genuinely the single most important mindset shift you can make for Cambridge exams. Listen closely. Examiners award crucial marks for the clear demonstration of process, not just for getting the final correct answer. You can actually earn 80 to 90% of the marks on a complex, multi-step calculation purely through method marks, even if you make a tiny arithmetic error at the end. To guarantee you capture every single one of those marks, top candidates use this 5-step standardized procedural sequence. Step 1, identify key elements. Ask yourself, what data is coming in? Step 2, apply relevant principles. For example, if we need to check if a value is above 0, we know we have to apply the JPN principle. Step 3,
Execute with clear working. This means writing down the contents of the accumulator at every single step of your trace table. Don't skip steps. Step 4. Verify results. Check your logic. Does the loop actually end? And step 5. Present the format exactly as the question asks. Following this sequence forces your brain to slow down, stop panicking, and it gives the examiner a perfect map of your underlying logic.
Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's jump straight into Act 3, Systematic Procedural Execution. It's time to build your success blueprint.
Now, the principal examiner reports highlight something truly fascinating. They note that candidates who reference cross-topic connections achieve significantly higher marks. What does that actually mean for you? It means if you're answering a question on assembly language using in and out, and you just briefly connected to the hardware topic, maybe by mentioning how the data bus and the control bus facilitate that input and output, you are showing the examiner an elite, holistic understanding of the entire machine. It's brilliant. Now, a highly actionable memory hack to encode these exact behaviors so you never freeze up is the visual story method. Picture a really busy airport. IN is the passenger walking through the terminal doors. The security scanner needs to check their luggage weight, that's JPE, jumping to the heavy baggage line only if the parity is even. Next, JPN checks their bank account. They can only board the plane if they have a positive ticket balance. Out is them walking down the jet bridge, and end is the airplane doors finally closing. By establishing these causal relationships in a visual story, your brain bypasses the panic of the exam room entirely. You'll remember the airport and you'll remember the code.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Act 4, we're stepping inside the examiner's mind to uncover the top 3 examiner traps.
I really need you to lean in and focus here. These are the exact pitfalls where smart, well-prepared students just bleed easy marks. These are the hidden hurdles of our decathlon. Trap number 1, forgetting overflow and edge cases in your assembly language trace tables. Remember, when a value goes above the maximum size the accumulator can actually hold, an overflow error occurs. You have to watch out for that. Trap number 2, ignoring boundary conditions. Think about it. If a loop is supposed to stop at 10, does your JPN instruction stop it at 9, 10, or 11? You have to trace that exact boundary or your logic is flawed. And trap number 3, which we've touched on, providing answers lacking specific context. If the question is about an automated greenhouse and your answer talks generally about inputting data, you lose the mark, period. You must say something like in reads the humidity sensor data. You absolutely must tailor your answer to the scenario they give you. Okay, let's put this into practice with a quick, interactive 60-second workshop. Listen very carefully to this response to a scenario about a security door system. The program uses IN to read the keypad. Then it uses JP to check the code. If it is correct, it uses out to open the door, and then the program will end. I want you to actively scan that data. Find the flaw. Which sentence is bleeding marks? Think about the specific context and the precise definitions we just discussed. Take a second. Do you see it? Did you spot it? The fatal flaw is this sentence. Then it uses JPE to check the code. That is a massive conceptual error. JPE checks if the parity is even. It doesn't magically verify a whole complex security code. Watch how the perfect Peel framework transforms this flawed answer into an A-star response. Point. The program inputs the keypad data. Evidence. It executes the IN command to store the raw keypad binary in the accumulator. Explanation. However, it cannot simply use JPE to verify the code, as JPE only evaluates the even parity of the accumulator's binary value, which is used for error checking, not credential verification. Link. Therefore, an alternative comparison instruction is required before the out command can trigger the door mechanism. See the difference? The Peer framework forces you to explain the why and link it directly back to the context. It's bulletproof. And now, Act 5, Mastering Comparative Analysis. Welcome to the higher order assessment. We are officially moving into the gold medal round. This is where you encounter those scary command words like compare, contrast, evaluate, and discuss. These questions demand that you evaluate alternatives and provide heavily justified recommendations. It is no longer enough to just describe how JPN works. You might actually be asked to evaluate the efficiency of using a JPN loop versus a completely different branching structure. Your analysis needs to highlight shared logic paths, so the similarities, but also the distinct boundary limits, the differences. you must explicitly use comparative connectives. I'm talking about words like whereas, conversely, or in contrast. If you aren't using those words, you aren't comparing. Ultimately, you must draw a justified conclusion about their relative importance, essentially telling the examiner which method is better for the specific scenario and exactly why. Let's bring all of this together into 3 absolute non-negotiable rules that guarantee top marks. Think of this as your ultimate cheat sheet. Rule 1, command word decoding. Stop rushing like Sam, underline the command word the second you see it. Is it identified, describe, explain, or evaluate? Treat them differently. Rule 2, peel framework application. Never just state a bare fact like Alex, make your point, provide evidence from the code, explain the technical mechanism, and link it back to the question's specific scenario. Rule 3, time management matrix. Allocate your time based on the marks available. Don't spend 10 minutes writing a novel for a 2-mark definition of JPEG, leaving yourself only 5 panicked minutes for an 8-mark comparative analysis. Be smart about your clock. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.